Okay, so I'm going to give you a task. Your task is to draw a structure chart for this program right here. Pause the video, give it a go. Okay, so what we should have you to do to start with is to look at what this program's actually going to be doing. What is this module going to be doing? So it's going to allow an input, it'll then output. And what's it going to do? It's going to allow an input of kilometers, and it's going to output the equivalent number of miles. So we're going to be doing some sort of conversion. So I'm going to call this program, or this procedure, shall I say, or this module, we're going to call it conversion. Now, this module has 3 different parts to it. It's going to allow us, let's see if I can do this better, to input our kilometers. We're then going to do our calculation, km to miles, and then we're going to output the miles. Pretty straightforward so far, if I must say. Okay, so now what we want to do is show the flow for different variables. Before we do that, I'm just going to draw my lines. So the variables we should have got would be our first one being number, so I'm going to do NO of kilometers, so km. So basically this. Now, in order for us to do this conversion, we need to pass the number of kilometers, so I'm going to do no km into this routine. It's going to do the calculation, blah, 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 blah. And we're going to then pass the result, which is number of miles. That's a variable, all one word, number of miles. Back to the main procedure. Back to the main sub module. Finally, we want to be outputting the number of miles. So, number of miles. And there we go. Okay, this next challenge is going to be slightly harder because you're going to use some additional concepts. So what we're going to do is a number guessing game. And I want you to basically make a structure chart for this following subroutine or submodule, is where we're going to generate a secret random number by the computer automatically, so like import rand. We're then going to allow the player to type in a guess. We're then going to basically output a message. And the message is going to depend upon if they get it right or wrong. So if guess is correct, say well done. Otherwise, say you lose. So to act this out, let's imagine that the computer's randomly got the number 6. We ask the user to enter in a number and they type in 2. It's going to output at the end, you lose. They don't match. So generate a secret random number, type in a guess, output a message depending on if they get it right or wrong. Turn that into a structure chart. Okay, So pause the video if you haven't already. What I'm going to do is show you a solution to this. Let's go back in time. So the program was number of guesses. So this we'll call it the submodule. We're going to call it number of guess. Actually, it's a guessing number. That's a bad name. So let's call it guess number. Okay. Now, normally we start off with an input. We normally then have a process, and then we normally have an output. So OPI. But in this case, it's going to be slightly different because we're not going to have an input to begin with. We're going to have a process. And that process is for the computer to generate a random number. So generate, we're going to call it random or secret number. That number, I'm going to call it GS, is going to get passed into the main subprocedure, or module, shall I say, the main module. Guess secret number, so GSN. We're now going to allow the user to input their guess. I'm going to call it guess. We also need a line. This line actually theoretically should be joined like that if we're drawing the diagram. And the variable, what we're going to be putting, is going to be called guess. So we've got two variables being fed in. Generate secret number, the guess, and now what we want to do is our output and our message. And to do that, we need to first of all pass, done these lines badly. I apologize. I've got a new stylus and it's driving me nuts at times. There we go. To do that, we need to pass the variable called guess, and we need to pass the secret number to this little procedure. Now this procedure is going to perform a process as well as an output. It's going to check to see whether our guess equals our secret number, the generated secret number. We then got yes and no, or true or false. If true, output, congrats, or well done, or whatever. If false, output, you lose. And there we go. Let's do another one. Okay, so this one is going to be quite a big challenge. Have a look at it and break it down. Pause the video, give it a go. Okay, so what I'm going to do is I'm going to look at what is needed, etc. So we've got a login with a user ID. So that's going to be an input. So I'm going to put input here. I'm just going to do I and O for input and output and P for process now. We're storing this information in a 1D array. Okay, fine. In two 1D arrays. The algorithm will search. So by searching, it's going to be doing a process. And you'll need the ID and the password to do that. The user is given 3 chances. So if it's 3 chances, it's going to mean that they have an opportunity for it to be looped. So I'm going to make a note of that. We need a loop to input the correct password. If the correct password is entered, you get a message. So we get an if as well. If the third attempt is incorrect, a warning output message is displayed. I'm guessing if after 3 times it fails, we want to give a message saying like denied or can't go in. Okay, so we're going to call this login, where we're going to have input user ID. And let's do a variable user ID. We've then got the password to be inputted. So these are 2 separate aspects, 2 different arrays, 2 different procedures. So don't combine them. Oops, that doesn't need an that, it's just a line. Let's just do that bit again. So we've got a line. And this is going to be our password. So I'm going to do P for password. Inside our input password, we're also going to have something which counts the number of times we've tried to log in. So I'm going to call it A for attempts. So we've got user ID, P which equals password, and A for the number of attempts we've tried so far. Now what we want to do is check the password, which is our process. And to do this, we need to first of all pass the password as well as the number of attempts. At the same time, we know that we're going to give them 3 chances to run this program. So I'm going to do a loop, which is an arrow which looks like that. And the condition for this loop is going to be until the password equals the one which is stored in our array. So until the password equals the one which is stored in our password list. So I'm going to do equals stored password list, or our number of attempts. So I'm just going to do A for our variable attempts equals 3. And that is linked to this loop. So now I've just done this, which is this arrow, which says we want to keep looping all of this 3 times or until we get it right. We're also passing the number of attempts to this check password because we use it again. Now what we're going to do is, does our password equal the stored password in the array? So SP equals stored. If true, we get output success. Now, before we can do access denied, we need to check to see if they've had 3 goes. So we're going to do, does the number of attempts, so we called it A, didn't we, for number of attempts? So if A equals 3, then we're going to say output denied. Otherwise, do we have a message to say if it, okay. wrong. Output wrong. There we go. And this, in a nutshell, is this program done. Let's do another one. So for this next question, it's actually broken down into two. One, a pseudocode, and one doing a structured chart, filling in the gaps for the labels A, B, C, D, E. Pause the video, give it a go, and I'm going to go through both, but one at a time. Okay, so I'm just going to do A, B, C, D, E. So what we want to do is, another random number generator is to be tested with a range 1 to 20 are generated equally frequently. Okay, initialize the tally. So if we call out the number 4, that basically means we call it out once. If we call it out again, we call it out twice, 3 times, etc. So we're doing a tally. For each number 1 to 20, repeatedly generate the numbers 1 to 20. For each number generated, increment the relevant count. So we want to increment our tally. Calculate how often each number should be generated, so an expected frequency, output the expected frequency, and output the list of numbers. So we've got update and output already done. So what we want to do to begin with is, for A, we want to initialize our tally. That means start it on 0. So for each number between 1 and 20, we're going to start them on 0. So A would be initialize the tally. So B, I'm hoping it's quite obvious. After we initialize the tally, we do our random numbers. We can tell because of this bit or this variable. So B, create random number, generate random number. I'm going to do GRN for generate a random number. Now, we've been given variables for other aspects. So, our tally goes in, our random number goes in. So let's imagine the random number is 15. Fine. What do we want to update? So this says update tally. So what we're going to be passing from here to this? Well, we want to update the tally, the count, the tally. So that's the variable we want to be passing through. Now, D can travel both ways. So we've updated the tally and we're passing it into the main code. So that's also going to be tally. And finally, we're going to output tally. But I've made a mistake. Let me just go through this again. We also, C isn't actually tally, D's tally, because it could be passed to the main code, sorry, to the subroutine, and back to the main code. So that's the tally. C is going to be, for each number generated, increment the relevant count. So it's going to be the random count, the random number. So random number, because it's going to pass, let's imagine that our random number is 15. It's going to pass that 15 to update tally, and it's going to update it to 1. If the next number is 6, or let's say 3, it's going to update our our update tally by 1, where the random number was 4. So we do need to pass this random number into update tally. And finally, E, we need to actually output our tally again. So we need to pass tally. So tally has been used a lot. Okay. What I like to do now is for pseudocode for this. Give it a go. Pause the video. Okay, so what I've done is I've just initialized these variables to make it easier. So what I'm going to do is I'm going to turn this into pseudocode. So what we want to do is initialize a tally for the numbers 1 to 20 and store it in the array. So we want to do this. So I'm going to do declare tally dot array 1 to 20 of integer. Now I want to call this initialize tally, which is this one. So I'm going to call initialize tally. Whoa, initialize tally. And what I want to send to it is the tally array, which is doing this bit. Now, we can see that we've got a loop going on here. So, and it's going 1,000 times. So, for which needs to be actually indented, my apologies. For count 1 to 1,000. What we want to do is run B, which is generate a random number. I just call it GN because it's shorter. So call this. And we want to do it from 1 to 20. And I want to store it in random number. This is meant to be indented, so let me just do this bit again, badly done. So we want to generate a random number to 20 and store it in random number. Then what we want to do is run this. So core update tally. And what we want to store in it are these two parameters, random number and tally. So rn tally. End4, so end 4. Oh my gosh, I'm not going to have enough room. And then finally, core output tally. And the parameter is going to be tally. Now, why is it that I'm only going to be looping B and update tally? So generate random number and update tally, not this and not this. Well, the arrow starts at B and finishes here. If it was like this, it'll loop the whole program. If it was like this, it would loop just output tally. So here we start and it crosses these two lines, so it's those two things which are going to be looped.